Thanks for joining, and I am pretty excited to really deliver on the plans of how we will be moving from NSX-V to T. But obviously, we need to have a basic understanding about NSX-T, what is all about, and why we are going in this path. That is more important to understand about it. Why suddenly, there's all hype that has been coming up that we need to migrate from P to T, as well as how we will see there would be difference in the network, especially on the virtual networking, and what are the new services which we are going to expect in NSX-T. These are the topics which I'm going to deliver today, but there would be further on sessions which we can plan, and we can talk about how we would be doing a better designing, which is being we will try to compare with our current design, and then we will try to see how we can redesign and restructure our full architectures. Similarly to that, how we can apply some sort of automations, or can we apply infra as a code, because if we are making a changes on the baseline of the network, um, so we can actually have a better opportunity to restructure our whole infra as well as operation part. Just going into the thing, so let's look like that. Uh, 2 o'clock. So we have another call? Yeah, it's a WebEx one. I've shared the WebEx link. Yeah. I'm sorry. Okay, I see folks will be joining on WebEx. They joined on Teams meeting. So I'll allow them to. Okay, so thank you everyone to making out the sessions successful, and we would be exploring the options of why we should be moving ahead with V2P, what is basically required, and what is the major changes which we are going to see in the virtual networking, that the part that we are going to really verify, as well as how the architectures options that we can have so that we can actually do the redesigning of our whole infra. So we'll try to take this opportunity to, first of all, make our baseline very strong so that we will have a basic understanding, whatever the terms that we are going to tell now, like what is P0 networking, what is P1 networking, what is DR, what is SR routing. So these are the terminologies which you will be going to be thrown back all the time. Okay, 1 second, I think Sam is asking. I shared in that very meeting as well. Okay. So I'll first of all walk through what are the services that we can have in NSX-T. I'm not going to make it more boring from presentation point of view. It's going to be like the basic business slides that I will walk through. But my major focus will be on the labs, how you can actually create your own infra if you want to really practice on it. And I will give you the options how you can explore on the actual labs. So these are the things that I'm going to cover in today's session. It's going to be a very basic baselines, which I'm going to cover down. But in the next sessions, it will be more detailed one, deep dives that we have to make it out, which could be on a performance basis. Maybe we can take one another sessions. It can be a full sessions. Similarly, how the routing architectures is going to get changed. Again, we can have another few sessions. And similarly for the security and automations, whatever. So I would say this is a nice opportunity that we have got to understand how public cloud experience we can bring in the private cloud. And on that basis, only the NSX-T was developed. So uh, if I try to introduce myself, so I have seen this development part of NSX-T when I was back in VMware. I've seen the dev versions of it, like when it got started from 1.x version, and when it was introduced to the customer, then it came as like a 2.x version. Some historical things that you would also get to know. First time in the production NSX-T was implemented in VMware on AWS Cloud. So I was a part of that very team. So we saw what are the benefits that we got when we had deployed NSX-T. In the way of operations, even from an architecture and even from the troubleshooting point of view, if we face any troubles. So on that basis, let me just walk through the basic slides, and then we will walk you through the labs what we have created. So that's going to be more easy for us. So virtual cloud network framework. Obviously, VMware has the vision that we need to connect each and everything, which could be any endpoints, could be containers, could be VM, could be the new kind of microservices. And obviously, it's going to bring us the same sort of feelings what we get with the public cloud. The same experience we want to get in the private cloud, but with this, with the better resiliency, with the scalability options. But obviously, those things we need to plan as a platform engineer or whatever like implementations that we're doing. Because whenever we get any kind of technology, it's more important to understand the features, what are the roadblocks that we can get with those product lines. And on that basis, only we need to architect those solutions. So obviously, there would be a lot of comparison between the Cisco and VMware solution. So Cisco provides an ACI solution, which is very similar to NSX portfolios. And NSX come up with NSX-V as well as NSX-T as a solution. So why there was a requirement to move from V to T? It's all about the new feature, the new coding, which was expected to be done from VMware. That's why they move it from V to T. Because if you will look out to the history of NSX as a portfolio, it was an acquired product from Nutera, where like the baseline coding was done, but further on changes which was required in the codes, it wasn't possible. So obviously we have seen really nice and niche features from V, which brought us the ideas of DFW, how we can actually have a software-defined networking without any hardware. Obviously, VMware doesn't sell any kind of hardware. But again, we didn't have a really good opportunity to make out like multi-tenant environment, though like somehow we did that part. But that set of experience you will be getting with NSX-T. So that is the one promise that I can give you. Obviously, most of the customers are now moving from private cloud as well as public cloud. But again, it's always a debate whether customers will be sitting on private or it will be public. But anyhow, NSX tends to fit on both of the cloud options. So it could be private and it could be public. And on that basis, it does fit with a public cloud environment. You can create a set of policy which can be distributed all across from a private cloud, whatever the policy that you're writing, it can be written the same thing on the public cloud space also. Obviously, there's telco networks which has been onboarded, where like you will see IoT programs. These are the things which is very common. Again, these are the things which you would be again expecting to be onboarded on the NSX-T portfolios. So this is all about virtual networking framework, what you would be seeing. I don't want to bore you guys on this basic slides again. For portfolio wise, let's really focus on VMware. So obviously, like VMware has moved out from the compute virtualization, and it has been trying to virtualize a lot of solutions, which could be on network side, even from the storage side, and even to give the better experience from an operation and even from the implementations. So you might be seeing there would be not a number of new products which has come up, like we realize, which is one of the best solutions for the automations, which you can see. Similarly, how VMware has moved into the public cloud with a solution on Azure, AWS, on the Google nowadays. So you'll not have very different feeling. You will be seeing that the backend hardwares will be of public cloud, but again, the upper, the front line will be the solutions. So that are the things that you're going to see in the NSX portfolios. But again, everything has to fit in. It be a security part, which is more important for us. And the elasticity, extensibility, all this kind of basic lines which you're going to always check it out in the NSX portfolios. Okay, so use cases of NSX-T data centers. First thing is the security. Obviously, that's always on the top points whenever we try to build any solutions. So what are the new things that we want to see that we can explore on NSX-T? I would say from 3.0 version, which is the kind of a new version. And just for your information, yesterday night there was a new update that came up with 3.1.1. Not major changes, but again, I would say from a security point of view, you have like a distributed firewall system, which was there with NSX-V. Similarly, you have a distributed IDS and IPS options that you can actually explore. Probably in the next sessions, we will try to talk about what will be the benefits of it. It's going to give you the multi-cloud networking options, which you can actually put into any public cloud spaces. That is also one of the options. Automations, it is like in open source codes, which you can actually explore. You can actually use Terraform, with the automation tools that you have got in-house, you can use that. And obviously, like it's going to be a cloud-native applications, which you can onboard on the NSX. So you would be seeing a lot of some solutions of containers. It's now getting fit in with NSX-T. So you need not to go and buy multiple other solutions on it. You can just run NSX-T and you can have many number of options that you can explore on it. Okay, so what are the features that is more important for us? What are the features which will be important for us from our data centers? What we currently host, and what are the features that we have to really focus on? So obviously from a platform-wise, there's a huge changes which you would see in the NSX-T. With NSX-V, you had one option to onboard ESXi servers, which was VMware solutions, but now you can actually onboard KVM, Ubuntu, virtualization solutions also with NSX-T. So the idea is that if you create a new policy, which could be for VXLAN, could be for the routing, it can be programmed to the Red Hat solution or even to the Ubuntu solutions. But obviously, we need to check the what are the versions which is compatible with them. Obviously, it is going to support your public cloud spaces. You can run the show on any of the public cloud, and as like an on-prem guy, like you can write down the policies and you can see that the effects will be coming up. There's going to be huge changes on the edge point of view, and probably we will be more focusedly going to talk about what is the changes with the edges. Just from an experience, when we tell that edges in NSX-V, I always see it as like a basic router, which can actually do the routing stuff. It can basically do the basic firewalling, mapping. But we have to run instances in our data centers, and then only the routing can achieve from one VXLAN to the other VXLAN. But now with NSX-T, we will be seeing how the container as in routing instances going to fit onto the nodes. That's the major beauty of NSX-T. So, and I would say that this is going to be our major use cases when we will be re-architecting we're going to like move from V to T. Like, if you guys know, like, how many number of edges that we are hosting, any idea? Like today, we have many number of orgs of a lot of customers, and we have to run a lot number of edges, right? So anyone, how many like edges we have right now in our data center? Let's make the sessions more interactive so we can actually understand what are the major problems and we'll try to achieve that.
Maybe around 200.
I think it's very less number.
Okay.
I think it's about 800, right? Phil, you probably know from your tagging.
4 times more than what you said.
Exactly, and that's a very huge number, 800. And obviously, like when we are hosting a multi-tenant environment, we can expect that number of edges. But again, is it really required for us? Maybe. It could be yes, it could be no. We need to really explore that options. We might have gone with the solutions of distributed routing, so that can actually save a lot of problems. And these are the part that we are going to really solve with VTT. Like with less number of edges, we still want to really explore a lot of options into it, and how we can make it more resilient as a solution for our customers. But plus, the features that we get, which we are going to not going to make the changes, it's going to be overlay technology, which is equivalent to VXLAN. But over here in NSX-T, we are going to tell it as a GINI, as in tunnel. But ultimately, as a backend technology, it's a VXLAN technology itself. Now, you would be seeing there would be more option to control your VXLAN. You can actually apply a lot of number of LAN-related security and LAN-related QoS policies. So we will try to explore those options. Obviously, we would be having a distributed routing as an main key part of NSX-T, which we will try to see. We will be going to expect that there would be ECMP, which is always a baseline of our routing. We will be following the more redundant environment that can be done by ECMP. We will be seeing BGP as in support, which was obviously there in NSX-B also. Obviously, the major trouble that we face nowadays is the duplicate IP detections, which is not there in our NSX-B. Though like we can do, it's not a trouble, but again, this is one another thing that we can do explore. BFD and many other things, like VR applied and EVDs. So these are the things like as in services we can actually explore, but we need to see how features are stable, because these are the new features. We can't really go and implement that solutions. But the major thing which I really see as an major changes from V to P, it will be more like onto the routing architectures as well as from a security. Because if you would see VMware now with NSX portfolios, they are moving ahead and trying to onboard a lot of solutions of security, which as a really a good features is the distributed IPS and IDS. So when we really talk about NSX portfolios
has
now,
joined the meeting.
so we'll see that we will be having a architect peoples who will be more focused on onto the networking, but at the same time we will be having a security focused people also, which can only focus on how we are going to provide the endpoint security, how we can do the investigation if there's any hack hasn't happened. So that's again a very different aspect of this. But again, as a basic networking solution, you get most of the features on it. But again, if you ask me, do we get a very security solutions as like we get with the perimeter firewalls? I would say no. It will still take a time, but we'll try to explore that whether it is required or not. But again, let's move ahead and we'll try to check out what are the other things that we can do. Obviously, we would be seeing a lot of number of platform where people are been doing a lot of number of automations as per their need, and we will try to even explore that what automation features we can enable in our data centers, especially on the NSX-T layers, which can really give us a better way of providing the services. The other things could be a private cloud integration with OpenStack and other things which you can really check it out. Operation-wise, I would say the major, like what I know about this product, the good thing is the upgrade part of it. When you talk about V upgrades, it has been always a tough task, I would say, because you have a very distributed nature of the product lines. Like the number, as we told, we have 800 number of edges. So when we have to upgrade, it has to be 800 number of boxes. So it's always a tough task. But again, you would see there would be a new services which has been put into the codes of NSX-T is the upgrade coordinators. So which really makes our life easy when we try to go for any kind of version upgrades. But obviously, from an operation point of view, you would see a single glass plane where you can actually write down your related policies, which could be for a basic networking, could be for your security. You can have a really good experience from a dashboard, which was basically missing in NSX-V, what I would be really doing. From a troubleshooting point of view, it's a huge changes because I've seen people over here struggling to really understand how this network is being working, how this VM is talking to the another VM, we don't have any clue. Okay. And that's the another key part, what I see about NSX-T gives you a really good features. You can look out to the topology, you can understand what is the VM part of it, information. The good feature is the trace flow features. If a dumb guy doesn't know how the traffic is being moving, he can just look out to the source and destination and he can do the trace flow of source to the destination boxes. And obviously the network topology views, which is always necessary.
Has left the meeting.
Because network of virtual networking has been always a difficult task for anyone to understand. So that view is going to be, we're going to get from NSX-T that we will see. And obviously the other features which you would be seeing as common features. Now I'm going to really walk you through the major building, what is all about and what is again architecture changes. The major architectural changes which you will see within VMP is on the management plane and onto the control plane. Because whenever we talk about software-defined networking, there are three blocks that you need to understand always. One is management plane, by which you do the configuration. Control plane, where you get all the information about your endpoints, and it makes you to understand what device is present at what very locations. Okay, and the data plane, the device or the entities which is going to be going to send your data from one point to the other point. So that is basically a true SDN, what as in language or as in definition that we define in SDN. Now we have seen there has been a lot of trouble when it comes to decoupling all this planes with each other, like management plane by which we configure the things. We have been doing that from our vCenter as a network and security task. So whenever you go to vCenter, there we basically do the config part of it. But at the back end, the control plane is basically the controllers. So you might have seen our data centers, like we have 3 controllers, which is like a brain of all the VMs where they are like located. So we understand each and everything on which ESX side the VMs are being sitting. And on that basis only, the policies are being pushed onto the related ESX sides. But now with T, you are going to see that your management plane and control plane is going to sit on the same boxes. You need not to really worry about to architect management plane in a different boxes and control plane on a different boxes. So this part is going to be a little bit more vigilant and is going to be more elastic from the deployment wise. Now, as an interactions from a user's point of view, you will be seeing 3 NSX manager, which is the maximum number that you can achieve. So you would be seeing you can't go beyond of that very limits. That's the 3 that you can club in. Again, from an architecture point of view, if these 3 are in different racks, equivalent to different subnets, we can put a load balancer on our top. But again, if it is fitting on the same subnet, we can go with the virtual IP concepts. So that three will be clubbed into single IP. From a backend point of view, VMware has gone with a new set of database called as Corfu database. So which is much better from synchronization speediness that you would be finding in another solution. So when you talk about vSphere, vCloud Director, they have the different database structures. But with T, you're going to see Corfu database is the baseline of the database approach. Now, when we try to interact, we try to interact with NSX Manager directly. We need not to go now with vCenter. So it is not clubbed to vCenter directly. You can interact with a manager directly. And whatever the networking related tasks you want to do, you can define on the managers. Now, this actually brings a little bit different from an architecture wise, where like you have to always club with the vCenter and the networking people have to really take a look from a vSphere how things works out. So idea is that NSX has to be always a different solutions that is going to be a purely network solutions. So a network guy is going to handle NSX, that is the whole idea. Now, obviously from a data plane, as I was telling, you have mix of both of the things. You can have a KVM host, you can have an ESXi host, you can actually program them, and you can bring them into the DVS, what is going to be created by the NSX. So that can be a DVS 7.0. Okay. So from 3.0, you will see that we can even interact with DVS or vSphere. Otherwise, you have to go with NVDS as an option. Now, this time, NSX Edges is going to be a containerization solution. So you will see that on a single boxes, you can have many number of instances of a customer. So that's going to tell that it's a true multi-tenant environment solutions. So we will try to actually explore that features more into the details, as well as the bare metal servers. I believe that we don't have this use cases in our data center, so we will not really explore that option. But for us, what is more important, VMs as well as the containers. So this could be the things that we can really explore. If I move ahead, I'll try to talk about. Okay. Before going back, I'll try to take down some questions if you have any questions. So then I will try to explain the lab, and then we will try to walk through some of the basic tasks. So today I'll basically move with logical switching as an option, and I will try to talk about how the routing will work. So these are the two things that I'm going to discuss. But any questions up to this moment?
Well, Abhi, what I understand is the integration is same as NSXV, but the only thing is how you manage the NSX manager and the control plane is little different. Like you will have a separate URL to log in. You don't have to connect to vCenter and then go to the NSX. Is my understanding right?
That's correct. And like I'll tell you some other things. We have to be always dependable on to the vSphere people to create any kind of code
Correct.
which could be a
I get that.
VLAN based. Yeah, even for the VLAN based, we can create it now. So
Okay.
the DBase that would be created on the basic size list, even a network guy, a dumb network guy can actually understand and can create the things. So
Okay.
this has been always a problem, like in any kind of big organization as an operation. What we are saying.
And one more thing, you said something about the NVDS and the normal VDS. Now, you said till NSX T 3.0, the communication between VDS and NVDS was not. After 3.1, they have an option. Is that correct or like missing
That's
something?
right. Actually,
Okay.
see, when NSX was introduced, it used to create its own DBS, okay, called as NDBS. So whenever you need to install an NSX, you need to have a separate uplinks. Like you should have more number of uplinks. Then you can actually move with the migrations. And this has been always an complaint from customer that if I have a current NSXV, how we are going to migrate if I don't have more number of uplinks. So obviously, like that was always in a roadmap from VMware that how NDBS can be still integrated with the DBS. So this has been introduced in 7.0, I think, with the 3.0 version of NSX-T. So that's why we got really opportunity that yes, now we can move on. But again, if you talk about from our infra, we could have done the migration, but obviously we need to wait and look out for the dependencies from VCD layers because our data centers are not on a native vCenter, rather it is on a VCD layers. And
Correct.
if we will walk through some of the limitations, there are many number of limitations also. So keeping that things as in mind, then only really we can actually look out to the migration phases, how we can migrate. Again, coming to your another set of questions, when you will take a look on NDVS will be still there. You can still create it, but VMware doesn't recommend nowadays that you create NDVS. Because if you have 7.0, why don't you go with DVS? Because when you go and create an NDVS, whenever you create a VXLAN, it will appear as an opaque network, and most of your third-party integrations can't be done. So this has been always a roadblock for the future. But still, NDVS will be the baseline of the switches in the edges. So edges earlier was like a black box routers, but this time it is going to terminate your VXLAN. So that's the thing that you're going to see. NDVS will be
Okay.
still there, but only on the edges.
Okay. Okay. Thank you.
Okay. Any other question? Okay. So if we don't have any question, let me walk you through what we have in our network layout. Okay. So obviously, when we go and deploy NSX as a solution, obviously we need some set of VLANs where we can deploy the solutions. So the baseline is that you should have a management network. Now that management network has to be where you have to deploy your NSX manager and as well as the controllers. Now, we would be aware about that we need to have a TEP communication, which is so called as a VTEPs. Again, from a VXLAN technology, it's a TEP package. So we need to have a separate VLANs for the VTEPs. But again, can I do NSX VTEP and NSX T TEP on the same VLAN? It's not recommended because ultimately the tagging of VXLAN in V is totally different what you would be seeing in NSX-T. That is basically called as G-meter. But again, it's a VXLAN. Now, as number of your edges increases, you would see that you need to manage those edges. So you will find out that edges will have this kind of management interfaces also. So you can even plan to have them into separate VLAN. But if you have spaces in your current management network, you can even occupy there also. Then there's a next set of VLAN which you would come across, which is called as an edge depth of VLAN. Basically, this would be only required if you have a collapsed environment. What I mean to say as a collapsed environment, when you prepare all the hosts with NSX-T VIPs, again, the baseline will be pretty same. Whenever you try to prepare any host, it's a VIPs that is going to be installed. So the idea is that if all the hosts in your environment you have installed the NSX-T web, then in that cases, it will be called as a collapse environment. So every boxes of ESXi will be capable to handle the VXLAN. So when you're going to deploy your edges, other than bare metal, because this time edges can be deployed on the bare metals also. But when you try to deploy the things on the VM form factors, in that case, you will face some troubles with the current version. So it's not a bug, but again, it's the basic routing issue what you're going to face. So if you have two VM kernels sitting on the same subnet, but again in a clustered or two level of virtualizations, you will find out that the communication will break. And probably like we can walk you through that very issues also. So basically to save ourselves, we can have two different VLANs. Okay, and we need to route the VTAP from compute VTAPs to the edge VTAPs. So that's the thing that we can really look out from a design side. But we try to solve this problem not by routing it, because I don't believe making the solution more complex, better to make it more easy to understand. Because we know the understanding of the DVS level. So in this case, we had to move with two DVS as an option. So one DVS that will be only and only for the edges, and one DVS that will be only for the compute level things. I'm going to go into the detail of it, probably not in the sessions. Okay, I just want to give you a basic understanding about it in the sessions. But if you want to really walk you through the deep dives, we can really get into that levels also. Now, again, the baseline again not going to be changed from V to T. So whenever you might have seen that VDOM communication that is going to the edges, which is our common design, that's the VLAN which is between tenant and the edges. So that VLAN is still required so that we can uplink our traffic. But now we would begin seeing there would be another set of VLAN which we should accommodate. That is basically for our multi-site options. So if you want to export your VXLAN from one data center to the another data centers, you can still do that things with the help of RTIP VLANs. That is going to be terminated on the edges boxes. Now, there are some obviously the requirements for creating this kind of solutions, which is going to be very ideal for our DR as in service when we provide it. Like today, if I have a customer whose solutions or whose VMs are there in HRC side, but I want to move into KC side, we have to do a lot of things from the network configurations. But now, with the help of VXLAN extensions, we can really solve that kind of problems a lot. So probably that is another set of options that we can really explore. Okay, so I'll not move more with the words, but rather I'm going to move ahead with the demo size. So from a demo point of view, the very important part is that how we integrate our NSX-T with vCenter. So that's the part like we will be trying to explore with the compute manager. Okay. What is the meaning of transport zones? We'll try to understand that part. What is the meaning of profiles? And what is the difference between the nodes of host as well as the edges? So that is the thing that let me try to walk you through. Okay, so I hope you are able to see my screen. Okay, great. Okay, so this is our one of the vCenter. Okay, just for the lab purpose only we created, but right now it isn't having some production VMs, but I'm not going to really make it very large. So let's try to see this out. So we have one data center thing in that way. We have a cluster of E6i boxes, which is being present over here. And in the same boxes, we have already deployed NSX-T managers. Now, installing NSX-T manager is a cakewalk again. It's not a very difficult task. It's just the appliances. As like any solutions, you try to install it the same way that you're going to install it here also. So after installing it, obviously you're going to get the IP address, whatever the IP where you have deployed it. If you notice out over here, I have deployed into our management network, and I'm going to use 141 as an IP. Why I would be using 141? Let's try to explore that first. So whenever you log in as an operation people, what you're going to really see this time. First thing is that you need not to really worry about from a vCenter point of view. We are not logging on vCenter. I'm a network guy. I want to see network parts only. I'm not really looking out for the compute related things. So what the first thing, obviously, the first part is alarm. We should not see the alarm. Though it's right now in a lab environment, so we were testing a lot of things. So you'll see there were a lot of tunnels that is getting blocks over there. And even there are some Tanzu edges which has been running, but Tanzu is hanging in a middle, so it does have some tunnel issues. Obviously, I'll try to go with this part, like what are the tabs. So the first tab is home, then is networking, security, inventory, plan and troubleshoot and system. So first is home. In home, you will get the overview, what are the number of gateways that you have configured. Gateways, you have to think in this way, like it is like an edges. But again, it's very different edges. How many segments, which is basically how many number of VXLAN, how many load balancers that you have as in service on the NSX-T, how many VPN tenants that you have. So this is again a very cool features which was introduced in 3.0. But as a networking guy, you will see this part from a security point of view, how many firewalls that we have created, that are the options that you're going to see. Inventory part, that is more binded with the compute people, where you need to do the taggings, probably on a tenant basis, which can give us an opportunity to write down the policy in a better way. System-wise, this is more an option which we need to control with the clubbing with compute people. So this is one. Obviously, the alarms, you would be getting the basic alarms. But again, you can define your alarm definitions. You can have a better control of defining the severity, at what level you want to create this alarm. So you can have that option. And you can have your custom um, uh, um, view also. So you want to create that things, you can actually have your own REST APIs that you can actually explore. So for a REST API people, for our in-house development thing, you will be getting API documentations in the boxes itself. So whatever the APIs which is available, you can find it out onto the same boxes. So like if I have to automate, if I have to pull out any information, I can get it in one shot. So that's the really great thing that you will see. But still, I do feel that the feature for getting the APIs, maybe you have to have API recorders. Whatever you're trying to configure, you can record it. That option is still missing out today. But still, it's fine. We can have the other way. Now, moving to the next one is the networking. Networking is again, you're going to get the viewpoint of whole environment of the virtual environment. Like how many gateways that you have. So this gateways, you have to always assume that how many tenants that we have. Okay, so tier 0 is like per customer kind of concepts. Tier 1 is like how many number of edges that they have. Okay, like customer would be having a production app, a dev environment. Then in that basis, that number of tier 1s that we are going to create. But again, it depends upon us how we want to architect that. Segments, earlier it was called as a logical switches, which is equivalent to DVPG from a vCenter levels, but now it's going to be called a segment. But again, under the hood, the same things are there, like it's a VX. Again, you have a DNS zone, you can have a separate DNS zone, which is going to be more proper. And you can have a DHCP servers, IP pools, a lot of things that you can have. But there's another very great feature that I would see. For this one, we usually have to really go into network insight or maybe some another third-party tools we need to always explore was the network topology. So today, if I want to see any customer's environment from top to bottom, it's going to be more easy over here. But obviously, if you have tagged it properly, you can actually tag and you can filter it out over here. But again, if you haven't tagged it, still you have the option to filter the things in this filtering. So you can look out to the subnet. What is the subnet you're looking out? So let it be a customer has 10.1.1.0 customer like subnet. I can apply, and related to that filtering, we are going to get the topology. And it has been always a tough task to us understand that where the subnet is, what customers we are talking about. It has been always a difficult task. So this is the way how the network topology will look like. We will be having a customer base tier 0, and then we will be having the segments for that. Similarly, I'll just try to talk to you about like what is tier 0, tier 1. Then we'll see that part. But again, like some basic demos that we want to really go through. Again, there's not major changes. Again, VPN as a service, IPsec as a set service, L2 VPN, same options that you can find out. Security, again, some really exclusive new thing that you're going to see is not distributed firewall. We have seen these features already in NSX-V, but the one that we are talking about is the IPS and IDS. So probably like in some further sessions, we'll try to talk about what is the benefit that we're going to get with distributed IDS and IPS. So we can create some demos by which we can understand that things. We can have a network introspections, which can be for east and west whenever we try to integrate some another third-party solution that we can really do over here. And the way that we were doing the gateway firewall, still the same thing that we can explore on this option. So if I want to create any kind of firewalls, you can just go down there. You can choose down which particular gateway firewall you are talking about. You get the another option also, URL analysis. This is also another great features, like from the VM itself, you can record what are the URLs that a customer has been using it. So on a tenant basis or a multi-tenant basis, we can apply some set of policies. So if we find out that there's a threat of a particular URL, we can apply those policy and the things can be blocked in one shot. Again, threat detections. Again, this requires another appliances. We'll not try to talk about what is this part. Usually, this is an analytics tool of VMware, which basically learns your whole environment, understand the traffic flows, and it will suggest you to write down the firewall rules. So if a customer is not known about what firewall rules I should be writing it out, this particular tool can actually help you. Now, you might have seen Carbon Black integrations also, which has been acquired recently in the past by VMware. So even that integration options is also available. But from our experience, like when we were doing a POC with Carbon Black, we found not very satisfying results in respect to the Linux boxes. So maybe that are the things that we can really look out in the upcoming versions. Now you get some another option like flood protection, DNS security that you get from the VM boxes itself. So that are the other things that you can see. So this is morely focused on the security side. It's not more onto the compute and to the network people. Inventory, this is another option that you would see where like different services, you can bind it. So if we might have used Fortinet and Palo Alto, we try to group the different applications and then we try to write on the policies, the same understanding that we're going to get over here. So it has come to the level of L7 application related security boxes that we can think about. And on that basis only we can apply the rules in our boxes. Now, one great thing, you will see that the virtual machines will be inventoried by the vCenter. So if you want to tag any of the VMs, we can actually tag it from the NSX layer. So you need not really depend on the compute people. We would be able to do the tagging and we can apply the policies. But earlier it was always to have integration close interactions with compute people to tag the VMs and then we can write on the policies. But again, there's other way also we used to really do. I'm just making it more clear. Now, one other great thing that you would be seeing is the containers as a service. So we were doing some sort of POCs where like the different namespaces and the clusters they created. So even the container as in security we can provide now. So that's the another option. And obviously the physical service, we can attach that things and the delivery tabs. But the another great thing that I would tell you about is the plan and troubleshoot in all your whole environment. Like the first thing is that discover and take action, but again, it needs to have intelligence. But let it be. If I have to troubleshoot anything, I would try to go through the trace flow options where let it be if I have to go down from VM to basically VM number 3, like Ubuntu 3, see it detects the IP addresses and you can trace down the things. So this is really a good feature which you would be seeing other than like network insight. So in network insight, you have to go on to the different boxes and try to understand how is the flow. So you'll be able to see that how the traffic is being moving from one boxes to the another boxes. So bit by bit, different paths will be shown, like up to what policies it has been hit and where it has gone to. So this is like over all the basic features which I'm trying to work with you guys. But when you onboard the things, that has to be controlled by the system. Okay. So obviously these network security and inventory and plan and troubleshoot will come into the operation phases. But when we try to implement any new things, it has to come onto the system levels. So today, if I'm implementing anything, I have to use this stats a lot. So as a system overview, it will tell us about what is the overview of our whole system, up to what limit we have really achieved it, like compute managers, how many compute managers we can connect. So this time we can have a single NSX manager and we can control around 16 number of vCenters. But this is again a major architectural changes. Earlier we had one NSX manager clubbed with only one vCenter. So it has been always a difficult task for us. But now a single NSX manager can control your within the environment around 16 number of vCenters. So that's the another benefit that you will get. But one thing that you would be really looking at out, this part, edge clusters, system-wide edges made. So don't you see this number is very less? 320?
Actually, in VCD, we have around 516 edges.
Okay, so you think that yes, it is going to be very less number, right? You can't occupy the whole data center, right? That things will come in your mind always, because when I was even doing, when I was doing this part, okay, this number is very less. Any comment? No worries. We'll try to understand why and how we will be trying to overcome from these things. Actually, customer by customer basis, we need not look out to the edges now. This part is going to completely get changed, and that's the thing I want, as in changes in our mindset. We need to come out of that very mindset that every customer, every application, we will have an edges. Like if any app, if any customer onboards, we try to create a single edge for them, right? No, we have to come out from that mindset. So that's the thing that I want from everyone, like to understand about this technology in that way. No worries. Then try to see. That's where like we just started. How we have implemented the appliances, it was not very difficult task in 3.0 version, I would say from 2.5 version. But earlier to that, it was always like you have to implement NSX manager, then copy the thumbprint, attach it to the another manager and try to make into the same cluster. But now it's going to be more easy. Just deploy. You will keep on deploying it, and the maximum number can be only 3. You can't go beyond of that. That's the basic sharding rules. The version that we are using is 3.0, but again, the new version last night, it was updated to 3.1.1, which has a major changes of support of OSP at this time. So that's the thing. So we have deployed 3 managers, but we clustered them with a virtual IP. So the virtual IP is 141, and this is the one that we are trying to use it. So if we try to communicate to this virtual IP, it is attached to 142. So 142 is kind of a master node, but again, it distributes its database to 151 as well as to 143. So if this dies, still we can still run the show. So the concepts remain same. It's not very different. So if let it be, it has to be recovered. What you can still do, you can create your own another NSX manager, put them into the cluster. Things will be synchronized with them. So pretty easy from the recovery point of view. Now, whenever we onboard, we can quick start. It depends upon what kind of data center that we are working with. Is it a micro segmentation as a solution that you want to really go through, or it's the VXLAN as a solution that you want to go through? So you can go with the deployment models also as a quick start, but we don't want to really go with this option. But what is more important for us, the Fabric options. In Fabric, you would see there's an option called as nodes. So you might be noticing me keeping like this word all the time. Like I've been repeating this term nodes. Actually, this came as in practice for me. So if I'll try to explain that, nodes is something as like for NSX manager. This is my NSX manager. I will treat each and every ESXi as a nodes. And similarly, edges as also as another nodes. Only the difference is that this will be called as a transport node and this will be called as an edge nodes. So on that basis, when you will take a look, we will see host transport node. There are some hosts which you would see as a standalone. So what it means as a standalone? The one which doesn't have a vCenter. So you will ask me a question, can we have environment without the vCenter? Yes, you can have. If you need networking as a solution, you can still do that piece without vCenters. But as we have a vCenter, which we have added through Compute Manager, so you'll see there is a Compute Manager integration. So in our environment, what you would be seeing, we will have NSX Manager, okay, which will be clubbed to vCenter, and this vCenter will be clubbed to VCD because we are working in the multi-cloud environment with the VCD as a solutions. So VCD can have multiple vCenters. That is also an option, but again, for us, it is right now single vCenter. So basically, we are controlling the vCenter directly from NSX Manager. Similarly, NSX Manager can be directly integrated with the VCD. So we'll see like how VCD will work on this way, but again, it's not major difference that you're going to see with VNT. The idea was that NSX Manager is being controlled as a separate appliances. So this has been added. Let me go back to the notes. If I go back to the notes, you will see we automatically discover these boxes. Okay, this is a cluster that we have got. So it does says that like 3 ESXi nodes have been provisioned over here. And the same thing that you're going to find out, 1 and 2. So we have already installed into it. So how to identify that whether we have installed NSX-T? Like basic idea, like from an ESX point of view. Or in a VXLAN point of view, from a networking point of view, if I tell that, when I tell that the boxes has the VXLAN capability, when it does have a VTEPs or TEPs, right?
Yeah, you will get a separate port group for VXLAN.
VXLAN port group, yes, that's the thing. Like we should have
VTEP. Sorry, yeah.
VTEPs. Again,
yeah, VTEP
like, from a network point of view, I would always say that yes, it's the same thing. Again, in Cisco boxes, Arista boxes, you will have the same concepts. You need to create taps, and in virtual world we call it as a VTEP, not a major differences. So what are you going to see on these boxes? The VM kernel adapters we have as in 2. We have 2 VM kernels as 10 and 11. This is going to be used for your encapsulation purposes. Okay? And these are basically used for our NSX overlay. Now, the question comes up how we installed Envoy. So this is all about the infrastructure as in preparation that we need. But obviously, when we prepare it, we have to count our whole infra, like how many number of NIC cards we have, what is the switches on the top. On that way, the policy has to be prepared. Like in this case, why we have 2 VTEPs? Just a question. Why we have a 2 VTEPs? Why we have 2 VTEPs on the ESX side?
One is for NSX and the other one for NSX-T. I mean, just my guess.
Again, misconception is one thing is that on a single ESXi, you can't have V and T. But on a vCenter, you can have V and T. Okay, ESXi boxes can't be shared for V and T. So this is actually the thing that you have to take in your mind.
Okay.
So again, why 2 VTEPs? Again, even you'll see on our NSX-V also you have 2 VTEPs.
Maybe one for the container communication and the other one for VM communication.
Yes, you can say as a redundancy, but again, redundancy, it depends. Okay. Bala actually answered redundancy as an answer. I would
Is it
say
one
it's for
for
load sharing.
management? Is it one for management, one for data?
Sorry,
No? I'm just
not for
guessing.
management, because management will be done by your VM kernel 0 only, which is on VLAN 6.
Okay.
And we also it does have the same concepts, not much. It's basically for our load sharing, nothing else. Like whenever you see an ESXi in design, it depends on the uplinks. Like you have an ESXi, okay, and if I assume that we have a two uplinks, one goes to one fabric, one goes to the another fabric. So if I create one VTEPs and I do have around 100 number of VMs which has to send the traffic, we will have only one way to send and load share the traffic. It's a similar concept what we have in port channels, right? Whenever we try to do the load sharing, we need more number of tuples by which we can identify how many links we have to use for our load sharing. So if I have only one VTEP, it will keep on using only one interfaces. But if I do have two VTEPs, it will choose one as another link, one as the another link. And as in like a data center designer, we need to always use what we have right now. Okay, we should not have like one fabric to be overutilized as compared to the another one. So if I am in any this set of design, you will see always there will be two set of fabrics that will be present on the upwards. So that's why like we have created two videos. But again, question will be coming up how we created it. Okay. And again, there's another mystery. There's another one, 169.254.1.1. What is this? I don't want to throw this question right now because it's going to be a difficult one. I'm telling you why this
That's
is
for
going to be.
API. Is it for API?
No, I'm sorry. This is not for
Okay.
it. Okay. This is basically to for the edges. Edges VXLAN routing, and I'm telling you the routing will be a little bit complex this time. Under the hood, it's going to be complex, but over the hood, it's going to be more easy. Okay, so if I talk about this, all depends how you configure your NSX. Right now, when you will take a look, you will see that NSX has been applied over here successfully. And the other boxes is still asking that I have to configure myself for the NSX-T. So it is still not prepared right now because this host has been newly added. We have just added it and it is still not in the maintenance mode. So think in that way, like we have two switches from a networking point of view. We have two switches which is available for VXLAN. The other third one is still there. We need to onboard it. Okay. In ACI also we do the same thing, right? Like whenever a new switch comes up, when we want to onboard, we onboard them from our code boxes. So if I go back and if I take a look on this ESXi, I'm just following through right now what we have configured. I'll try to walk you through what is the way of configuring it. We'll see that this is the ESXi boxes. It does have these IP address and the VLAN that I have used is VLAN 150. So I have gotten two IP address from one VLAN 150 that is for load sharing. When you take a look, there's a transport zone concept. Okay, it's very important to understand what is transport zone. Okay, we'll see the next thing is a monitor. What it is being monitored. Obviously, we would be able to see the health count of ESXi boxes, like how much we are utilizing it. And I would say this is a true changes from the V-centric models. Actually, earlier with NSX, whatever mesh it does is to the ESXi, we were not able to really understand about it. But now with the help of NSX Manager and team, we will have a totally viewpoint what's happening on the ESXi's list. So that is a thing. Now, obviously, we will be able to see how the monitoring has been working. It's healthy, physical adapters, all those kind of counts we will be getting. But the very important point will be switch visualizations. How switch will be visualized from an NSX-T point of view. So you would see that there are some VM kernels, which is basically used for some different purposes. But when you take a look, this DVS has an uplink number 1 and uplink number 2. Guys, just keep these things in mind. This is going to be used right now. Why we tell it as uplink 1 and uplink 2? Where we are going to refer it. So we told that it is going to use VNIC number 4 and VNIC number 5. And this is the DVS that we have prepared. So on that basis, how this configuration is being done? It's basically done with the help of a profiling. So profiling is nothing again. If you have an experience working with ACI, it's the same concepts that we have got. We create everything as a policy, as a profile, and we keep on using it again and again. But obviously, don't mess up with your profile because it can actually break your full infra. So we have to have a better controlling on that. So on the basis of profile, what is profile I think? This is all about uplink profile. Okay, so what is uplink profile? This is a profile that I have created. So guys, you'll see that you feel that we have two sets of profile. One is called as a default profile and one is called as a name profile. Okay. The name profile is the one which we can customize as per our infra. But this default profile will tell us that when you have 2 uplinks, when you have 3 uplinks, or somewhere like that. So I have created a profile where I have written that it's an active host profile. And if you take a look, I have used the load balancing as an source MAC address. And I have told that we would be using 2 sets of uplinks. And this is the same thing that we were seeing in the visualization. We told that we are going to have 2 uplinks on the cloud. Now, if I would have 4 uplinks, we could have created 4 uplinks also, by which we will be going to achieve more number of load share, nothing else. You can even have an active or standby. So one will be always used. If that fabric goes down, then we will see the another fabric will come up. There I have written 1959 as my transport VLAN because my VTEPS is going to run on that VLAN itself. And we should have an MT of 9,000. So the least the number that you can get is 1600. But again, this number totally depends upon what is the DVS MTU you have configured. So as well as the underlying infra. So we should have always an 9,000, which we are good on that, not a problem. And that's going to really bump up our performance. So this is the thing that has been saved. But again, this is the profile. But I wanted to have a cluster inform kind of configurations. So you would see that this is the profiling that I've called, but there's a concept called transport zone. So what is transport zone? Let's try to understand that part. Right now, what we have just done, NSXi will have 2 uplinks, okay? And we have told that it's going to load share on the basis of source MAC. We have told up to this point. But again, where it will be configured and what will be configured, it has to be defined with the help of transport zone. So transport zone can be of 2 types. One is called as a VXLAN based, and one is called as a VLAN based. And yes, it's a new thing. And NSX-T, we can even create a VLAN based port groups also, which was not possible with NSX-V. That's again a major difference. So we need to create 2 sets of transport zones. Now, again, questions will come up from a design point of view, up to what level of transport zone that we can create. It totally depends upon, again, like if I do have a compute nodes, we will be creating a transport zone which will cover the whole VXLAN. Now, if I do have edges, which will go and connect to your uplink routers, that will be VLAN based. So over here, we will be having a VLAN based transport zone. So this is the thing that you're going to see as a major differences. But again, in our infra, I want to really extend both of them in one shot. So that's why we have called both of the transports. And we have told that whatever that things, any ESXi which comes a part of this cluster would be having this set of policies. Obviously, I have also called the IP pool. I have already created the IP pool, which you would be able to find out in the networking. This is the IP pool that I have created. So whatever the devices is going to get the VTEP IP, is going to get from this particular blocks. So again, when we plan it, totally depends upon how many number of ESXi and what is the load sharing method that you're using, like what is the number of VTEPs. On that basis, we need to plan the ranges. So if I come back to system, if I go back to nodes, if I go to transport nodes, the other one is still not configured with NSX. So let's try to prepare it as an NSX boxes. That's the problem with first one. I think we are doing some activities. And let me just exit it out from the maintenance mode. So now, the moment we make it out of got disconnected. It's asking that we need to configure NSX. We tell that yes, we can configure NSX. Okay, now this is the way how you can install. I was expecting that it should be installed by default the moment it came into that cluster. But this is the way how you can install it manually if it has not configured. So installing it just like what you have in NSX-V, the same way we will be performing. Just hit next. Now it will ask you a question, which model you want to go with, VDS or NDVS. So this was the old method, okay, but this is the new method. Now over here, you will be finding it out there are three options. One is standard option. Then there is an option of ELS and enhanced data path. Basically, these modes will be only can be explored if your hardware, underlying hardware has that capability. So it does have to have a special NIC card and specific ENIC drivers. And mostly it is being used for IoT and telco environment, where you can bump up your performance of your ESXis. But still, I can go with standard one. Which of the DVS you want to prepare? So I would tell that this is the DVS that I want to use. What is the transport zone? So I would say that I'm going to extend these are the transport zone. And what is our uplink profile? So I'll use this uplink profile. And what is the text? So I will use a pull that I have already used it. I created it. I think this is the one. It's going to ask me that how many uplinks. I'll tell that uplink number 1, uplink number 2, finish it. Okay, so it's telling that please update into you from these videos. So I use that. Okay, I think it has been moved to go back to DVS. I think we are doing some activities. Let's see that part. Uplinks, advanced, it is 9,000. It's fine. We can have unsupported MTO and updating profile. What I'll do, there's a hack in the process space. What we can do. I can just keep it at 700. It is fine, and then I can change it later. This is the one thing that I have found. And I guess that's why it was not getting hot enough to use for it.
Defender is walking around getting orders of you.
Okay, I think they have to call it. Next. NSX-T cluster, VXLAN, uplink profile, active host, and use data. See, uplink 1, uplink 2. If I'm still facing some trouble, maybe I have to troubleshoot it later on. I can do that.
By the way, the error is actually complaining about the uplink profile. Is it the uplink profile?
Yeah, basically, I should have done this one. If you would go back, I have just formatted the code. I can make it as 16.
Okay, okay, yeah, okay.
If I save it, and remember that whenever you make a changes, it actually affects on the current boxes also. So never ever change in the production environment. So if I configure it once again, next, NSX TDVS, cluster, VLAN, VXLAN, profile, use IPFL, update form, update. It actually take it from DVS number. DVS what uplinks that we've got. Maybe it is going to take up fact. I'll probably need to troubleshoot it once again. So we'll try to see that. But yeah, whole idea is that if we prepare it, we will be able to see the boxes will be capable to handle the VXLAN. So on that basis, let me move ahead with the another topic that is switching part. So if I talk about logical switching, again, it's nothing. It's basically VXLAN under the hood. Why we need VXLAN? We know the benefits of it. But again, on the top, we should have to make it sure that you have the redundancies from the logical network. We need to go off the logic of STP because that's going to block our traffic. If you need a non-blocking, then you have to play with your VPCs and many other things. But in the virtual networking, it's always good to have. Yes. So that's the thing that we are going to see in the logical switching. I would go with routing, but I don't see that I do have much time to really cover on it. But again, the idea is that you would be saying there would be a concept of distributed routing. Okay, so this distributed routing we have to categorize in two parts. Now the categorization will be either it is an SR or is it a DR router, or is it a T0 or is it a T1 routing. Remember, guys, this is very important topics, and this will come again and again. Okay, and I know that it's going to be a pretty confusing topic. Now, routing works as it is. There's not much major differences you would see. For east-west routing, you will have a different set of router. For north-south routing, you will have a different set of router. Now, we need to support multi-tenancies. So what set of design that you have to choose? It has to be really checked out from your from your environment needs. And whatever the services that you're going to get, you need to put into the related boxes. So on that basis, what is the major differences between it? So what is called as T0 and what is called as T1. So remember that T0 is very equivalent to like a TGW routing, what we see in AWS, which connects all the boxes with each other, like all the VPCs. The same thing you are going to experience with NSX-T. You will have a T0, which will connect all the T1s. So T0 is like a bigger router on the top and will be handled by any service provider. But the T1 will be the tenant-related routings, okay, which could be per application basis or could be a per environment basis. Could be like a production, could be test, or could be development. Remember that T0 will be having a support of static and dynamic routing. You can't have a dynamic routing on T1. So it is like a termination point for your VXLAN. So VXLAN will get integrated over here directly. But whenever it comes to the uplink routing, it has to integrate with T0. So whenever we tell that it's a T0, always think that it is going to connect to the uplink boxes. Uplink boxes could be anything. Could be our firewall, could be our VDOS, could be our Palo Alto, could be our Nexus, could be anything. But it will be connected to what? It will be connected to T0, not to the T1. Now, similarly, the ECMP can be only possible with T0. You can't have on T1. T1 will be always in active standby. So when you talk about T0, you can have around 8 number of ECMP that would be possible on the top of your uplink boxes. Now, the another thing would be what is the scope of it? Obviously, T0, when we talk about it is connecting to the uplink devices, it's basically for your north-south. But when it comes to your east-west routing, which right now we do with the help of edges, okay? So edges is actually doing our termination point for east-west as well as for north-south. But over here, the T1 will work as an only east-west routing. It can't really do north-south. Now, T0, where does it down? T0 you can't have without the instances. You need to have instances for that. So you need to have an edge cluster for it. Now, this boxes, T1, if you have a SR instances, now you will be talking, man, you're talking more detail now. What is SR? SR is basically you have to think as a service. So if I need a service of NATing, firewall, and other things, then you will need an edge instances. Okay. If you don't have any services on your boxes, then you can actually run it as a kernel process. Okay, it won't have any kind of instances that you have to run. Like you have to not spin any edges for that. So it's like a distributed routing architecture that you can see. But whenever you talk about T0, it has to have instances so that it can actually do the north-south routing. But I would say that absorb this topic more in detail, okay, because this will come again and again always in your head. What is T0 and what is T1? So on that basis, you will see there would be two types of topology. There would be topology called a single tier topology, where you need not to have tier 1. You can actually run the show with the help of tier 0. Now, this will be only done when a customer environment is a small environment. Okay, it doesn't have multiple applications sitting on different edges, or a customer just have like a smaller environment, like it does have a single environment there. So in that cases, we will be going a single tier. But if I have a customer who has like multiple applications, 4 edges, then in that cases we have to go with 4 tier 1. So tier 1, tier 2, and again, I'm not telling that it is per customer basis or tenant basis, but again, it can be really tweaked as per the infrastructures. So this is the major difference, the single tier and the multi-tier. So whenever we talk about multi-tier, it is only T0 that will come, T0 basis. But whenever we tell that's a multi-tier, you'll see T1 will talk to tier 0. Now, some of the basic questions, some basic things. Tier 1 will always connect to tier 0. Tier 1 can't connect to tier 1 directly. It has to go through tier 0. Look that things in your mind. One tier 0 to the another tier 0, it will always go through the uplink. It can't connect directly. Exceptions can be done. Okay. So you'll see tier 0, how we can achieve the uplink connections. Again, totally depends upon the environment. If you have a single rack environment or a dual rack running on a same VLAN, which is in our cases, we can have a single VLAN which will connect to the firewall or whatever the route is. Now, if I do have multi-redundancies from the VLAN basis, we can have 4 VLANs. Okay. Now, the major topics. This is the major topic, what I would say. What is DR and what is SR? Now, DR is basically only for east-west routing. Okay. Now, for DR, you need not to have the instances. Remember that. Instances meaning is that you need not to have any edges. You can still run the show without that. And it is being distributed on all the transport nodes, which is basically ESXi, and it can run even on the nodes also, which is edge nodes. So this is always a first hop routing option. Like we'll always try to do bridge route kind of concepts. We try to route it, then we try to bridge it, and then we try to route it to the other boxes or in the other sockets. But whenever we tell that SR is basically when we try to instantiate any services like as in MAC services, centralized services, or even it is going to be north-south routing. Then we will tell that that router is a SR router. Now, I would say it's totally confusing for some time, like what is DR and SR up to a moment, tier 0, tier 1, we understood it, but what is that part? I would say, let's try to absorb this part once. And let's move ahead and let's try to understand this topology. So what do you think in this topology? What's happening over here? Any idea? Like you created a router, okay? This router is distributed, okay? It does have a same IP. What the heck? It's a little bit confusing for me, right? Routing doesn't work in this way. This is actually the distributed routing. So in this case, you will see that you have a VXLAN, two VXLAN extended on both of the ESXi boxes. Okay. Now this VM, which is a part of one subnet, this is a part of another subnet, how it is going to route it. Earlier, whenever we had to route the traffic, this VM has to talk to edge. Okay, the traffic has to go and reach out to edge wherever the ESX, like wherever that edge is being hosted, route the traffic back to this ESX. But now in this case, what is happening? A router is created in every boxes. Okay, again, this will be created on the basis of realization. So when ESXi realize that yes, I need to create a router, and when I will create the router, when the VM comes up, then only this VXLAN as well as the logical router would be created. So this is the major difference that we call as a realized state and an unrealized state. Okay, that's the thing which you would see with the help of the control plane, which is working under the hood of things. So what happens over here? The routing will happen from one VM to another VM from the kernel levels. So whenever we tell that kernel, we need not to have a router on the top or like a router-agnostic kind of topologies. So routing is happening from a VM, it goes to ESXi. ESXi kernel will do the routing. It does the bridging, and this traffic which moves from one ESXi to the other ESXi, that is a VXLAN, and then it reaches to the destination. So always remember that routing always happens nearer to the source. So when this guy will send the traffic, it will not send to this router, rather it will route the traffic, okay, to the router which is actually present in his boxes itself. So routing happens, and then to the VXLAN, the traffic is. So what we are basically saving ourselves in this kind of situation. Like what is the benefit with this kind of architecture? Any idea?
The traffic, whatever is not required, will not go to the physical switches. It will be sorted.
It's switching, right? With the computer.
Yeah, it's a switching. Yeah.
You take that course out of maintenance.
I was. Yeah.
Don't. Break it out of put it back.
No, it's already in.
No. This one. New one.
No, I have not put it in.
You take it out of maintenance.
No, I haven't done that. It was like I think restarted, right?
No, it's been reboot.
Okay, I'm sorry, guys. Yep, Prashant, you told something.
Yeah, I mean the traffic doesn't go all the way through the physical infrastructure and then reach. It can
Yeah,
that
actually, that
VTIP
story will
that
be when. Yeah, that story will be when the VM is on the same boxes. Okay, right now it is on two different boxes, but still this is a VXLAN traffic. But yes, your story is right. When these two VMs on the same boxes, the routing would occur in the boxes itself. It need not really leave the VXLAN. So we are going to save a lot things and effort from east-west routing with this set of architectures. So that's the benefit that we're going to see. And I'm not telling that's the new thing in NSX-T. It was even there in the NSX-V, that is basically called as an DLR.
DLR, yeah.
Yeah. So now the same terminology will be called as a DR.
DR. Correct.
Okay. But this DR will be sitting on all the ESXi. Okay, it will be instantiated in every boxes as per the realization state of the VMs. Now let me go to the next diagram. Now, what you see in this diagram? Try to observe this diagram. This is very important. And I would say this will really make your logics right when you talk about logical routing with SR. So whenever we tell that SR needs always what? Edge nodes. Okay. Now in this topology, what we would see when we instantiate any logical switch and we instantiate with SR instances, the traffic has to go to the edges, but why it is basically required? Because we need to have NAT service, firewall service. So this will be like a same model what we have got with the edge models. So when we have a traffic which is going from one VM to another VM, routing will occur on the same boxes. There is no trouble. But it has to have like some sort of services. It has to reach out to the edges. And that makes a difference is called as a what is called as a logical router and what is called as a logical gate. So on that basis, let me walk you through. If I go to NSX and if I go to networking, I do have some setups there. Like if I do create a segment is where like you create a VXLAN. So if I add a VXLAN telling that this is customer number C, okay, I want to connect to what gateway. Right now, if I don't create a gateway, I just tell that it is the overlay traffic, okay, and I tell that this is going to be 192.168.1.0 slash sorry 1.254 slash 24, and if I try to save, this is what this is one VXLAN that is there. But if I write on an IP, but I don't define any edges with that, this IP won't be live anymore. It's just a VXLAN. So this VXLAN, I think I created this one. So you would find out, if you go back to this guy, you'll see this VXLAN is been created. So the VNI. Now, if I go back, if I go edit it, and if I tell that I need to club you with T1 gateway, like this is the one gateway, and save it. Now what we have instantiated? We instantiated that it would be a SR instances. Okay. When it will be SR instances? Because when in tier one, okay, we connected to which one? Let me see. Customer C, customer B, app one. I'll just go to that app one. If I go to edit, you'll see there's an option called edge cluster. So if I tell that I want to attach it to an edge cluster, like it is a T1 dedicated cluster, and if I save it, then the traffic will come into this kind of terminologies. But again, I not to go into the detail. I will try to expect that you guys explore it more, what is all about. Okay, this is a way like how anything are being connected with each other. Same way, tier zero, like if you want to see any tier one connecting to tier zero, you can visualize that in the network topology. So if you will take a look, we have one tier zero, okay, which is running on a VRF thing that we will talk about. But this has been connected. I think this is the one that we tried. So we connected to one of the tier one, and tier one is connected to a tier zero. So in this case, this is one of our subnet. Now, if I want to move this guy, let it be, I'll go to custom invoice. Edit it. I want to connect to customer number A. App one. Remember that I have something which is connected on the top, which is one of my VDOM. If I go back to my VDOM, this is one of our VDOM, but I can go out to next voucher, go out to table BGP. I do have a BGP. You'll see that network is getting advertised. So the moment I connect that, that is being advertised from our BGP routing protocol, which is running where? On the top of these boxes. So if we will go back to tier 0, and if I want to see for customer number A the topology, you'll see this is the topology that I have got. Customer C, this network gets connected, and it gets connected to our firewall. So how this is thing happening? Obviously, we have already created some sort of routing on the top. So if we go to edit, you'll see we have done the routing on the top. And who is my neighbor? Who is one of my neighbor? I do have BFD enable, which is going to give us the resiliencies in our neighborships. So if one of the neighbor goes down, we still will be having less number of packet pods, and we can switch the traffic on the other boxes. So that's the thing which we have from a logical switching and routing point of view. Obviously, we don't have much time to really go into the details, but obviously there could be a deep dive sessions. But again, I would expect that you go ahead and try to understand this technology more in details, which we can cover in the upcoming sessions. But for us, what is more important, what is the restructuring, how we will be doing operationality into it, and how we can explore the security part of that. Because the cool thing which has been coming up in the as a feature is the distributed IDs and IDs. So this is the parts. So I would go ahead with the questions. Like, if you have any questions, but again, as the next sessions, we are planning that maybe we can have a design discussions more in detail, but it will be like if we have the understanding, then only we can attend a design workshop. We will be doing some performance auditing, like how performance of NSX-T can be checked out as a benchmarking. More detailed deep dives we can do for security part, migration plans. What are the things we can really explore on the automation as an infrastructure approach, and how to troubleshoot and monitor the things. So if you have any question, guys, please feel free to ask questions. And I know, like I just walked through like a little bit fast on switching and routing, but I have like less than this.
When is the exam?
Okay, Abhi, I have
When is the
just
exam?
clarification here. Now, what I understand.